Okay, so we are doing question number 12 for homework 2. All right, let's see what questions we have. Four coins are tossed. Okay, we are doing probability questions. So let me see. A, give an example of simple event. So what is simple event? When there is no one outcome, only one outcome from the experiment, okay? Because there can be more than one outcomes, and simple event is only when we have one outcome. All right? So let's see which one is going to be. Let's go. Okay, we see the answer, but let's analyze. Getting ahead on no coins, which is no point, which is not possible. If it's we have coins, so there has to be head and tail. So this is nonsense. The answer: getting ahead, tail on all coins. That is not going to be simple event because on all coins, which means several outcome, right? So C, getting a tail on the third coin. Third coin, it still means one coin, right? That's why it is a simple event. And the last one, getting a head on the third coin and tail on the second. So we have here two outcomes, correct? Therefore, it cannot be answered. And this is why C is the only answer for this case. Moving to next one, B. Give an example of joint event. So joint event meaning when the more than one the events are happening at the same time. So let's see, what do we have? A, getting a head or a tail. This is not joint because it's going to be either head or tail. The keyword here is or, either or. B, not getting a head on the first coin. So it's not a joint event because only one outcome. Not getting head on the first coin. C, getting a head on the fourth coin and a head on the first one. So there are joint event, two outcomes at the same time. Okay, first and fourth. And that is the answer, obviously. And the last one, not getting a tail on the third coin. Okay, yeah, that's also only one simple event could be. All right, moving to next question, C. What is the complement of getting a tail on the second coin? Complement is meaning opposite operation. Let's say if I say it's raining, complement is going to be not raining. Okay, so let's see what we have here. We need to choose the complement. Which is of the following is complement of getting a tail on the second coin? All right, let's see. So getting a tail on the second coin and the head on all coins. That's a joint, right? Joint event. It has nothing to do with complement. Second one, getting a head on the second coin and the tail on all others. This is also joint. All right, because we have and, keyword is and. Now C is getting a head on all coins. There is no complement here because no, it's not opposite to second coin, tail on the second coin. And the only thing we have left, D, getting a head on the second coin. Here also is asking for the second coin. Here is asking complement for tail. If it's not tail, then it's going to be head, right? So that is going to be the answer. Okay. What else? Question number D. Question number D. Uh, what do we have here? What does sample space consist of? Sample space meaning all possible outcomes. Okay, all possible outcomes. Well, let's see. Which the following identify the sample space for the 4 flip coins? 4 coins. We have 4 coins are flipped. That means we're gonna have 4 outcomes. Getting a tail on any meaning 1, so that's not a sample, right? Space, getting a tail on 1 coin and head on all others. I think this question is wrong. Let me see. Sample space for 4 flipped coins. So what do we have? A tail on 1 and a head on all others. Yeah, that can be sample space. Every possible answer. And B can be sample space, not getting a head on all coins. And getting a head on or a tail on any of 4 coins. I see what they want to do. Okay, okay, sample space, it can be all possible answers. All possible answers is meaning either tail or head. So this if D wouldn't be there, then B would be the answer, but D kind of getting better, closer to better answer for sample space, because D said getting a head or tail on any of these 4 coins. We know if we flip the coin, it's going to be head or tail, and any meaning all of it, right? Every single coin on all 4 coins. That's why D is sample space. If version D wouldn't be, then B would be also sample space, because on one is a tail and head are on all others. So we got all the sample space. We have outcome for all 4 coins. Okay, all right. So moving to question number 13. Let's see what we have. An urn contains 13 red balls and 7 white balls. 2 balls are to be selected from the urn. Urn? I don't know if I pronounced right, but at least you know what I mean. URN. All right. So question A. Give an example of simple event. Remember, just refresh your memory. Simple event, it's only one answer. 1. So for a case of A, which of the following example simple events? Selecting no red balls. Just the fact is it's balls as given in the plural form, it's already no answer, because we can have only one answer. Next, the first ball being red and the second, it's also no simple, because you have 2 answers there, 2 outcomes rather saying. C, selecting at least one red, so at least, so it can be 1 or 2 or 3, okay, or 4 or all of them. So also not a simple event. Let's see what D says. The first ball being red is a simple event. Yes, it's giving us only one outcome, correct? All right, next one, question B. What is the complement of the first ball being red? All right. So since it says being red, complement for red, and we have what? We have red or white. So if it's not red, then complement is going to be white. Therefore, indeed, the first ball being white is going to be complement to first ball being red. And I don't even, makes no sense even going through all other answers. It's there is nonsense. Talking about second ball, Complement meaning has to be the same ball but different color. Okay, next one. What does the sample space consist of? Sample space consists of all possible outcomes. So let's see. Here we have 13 red and 7 balls. So this the long one definitely gonna be the answer, because look here, it can be red and red, red and white, white and red, and white and white, right? All possible outcomes, because there are the 13 red and 7 white. So you can pull out either 2 red, right? You can pull out either 2 white, correct? Or you can pull out red and white or white and red, correct? That's the only option you have here. All right, moving to next question, 14. So here we are going to deal with probability. All right, so most likely we will go with Excel spreadsheet. Let me close this one. I don't need to save. Okay. So let's see what we have. This is what we have. So use the contingency table, which is this table here, and we move to Excel spreadsheet, 80, 60, 90, 10. So to find out what's the probability of event A prime. So to find probability of event A prime, first of all, we need to, let me zoom it a little bit so it would be close so you can see better. There we go. So first thing, we need to find how much is total of A prime we have. And here is our A prime, which is going to be 90 plus 10, right? All right, let me do it. Although we know 19 plus 10 is 100, but I would like to use Excel. So we are going to, 1 second, we are using formula here, auto sum, and clicking these two. Okay, enter, and I got this 100. And I need to know overall the whole sum of all these total, grand total. So I have to get the sum. Let's say I'm getting here sum of all these 4. Okay, and that makes 240. So to find probability of A prime, I'm going to do probability of A prime. Okay, it's gonna be equal. What am I going to do? I need to do equal sign, take the probability of A prime, which is 100, total probability of A prime, and dividing by over grand total, which is 240. And that is going to be equal 0.4166. Let's see. 0.4166 rounding 417. Okay. Next one, the probability of event A and B. All right, let's do it. Probability of event A and B. What is probability of event A? Here it is 80, right? B is in the column, A is in the row. So A and B is gonna be 80, yes? So we are taking this 80 in this case, equal sign. I'm clicking on this 80 and dividing by saying 240. Grand total 0.3333. Let's see, 0.333. Next, probability of event A prime and B prime. Okay, A prime and B prime. Here is A prime and B prime. Intersection is 10. So we take 10 over 240, right? It's going to be equal sign 10 over 240. It's a grand total, 240. And we get 0.04160, 0.416, round 2. And probability of event A prime or B prime. Okay, when you have or, that means you need to find probability of A prime and then probability of B prime and then add them up. All right, A prime or B prime. Probability of A prime, we have it here already. Now we need to find probability of B prime. Where is letter B on my keyboard? Okay, here it is. B prime. And that is equal. So what we are going to do, how much is our B prime total? 60 plus 10, right? It's going to be 70, right? Let me do it all put in the form of formula. Okay, opening parenthesis, 60 plus 10, closing parenthesis, dividing by, overall is 240. 0.292 if we round it up. I'm sorry, or B. That's only A we found out. We need to find also B, and I'm wondering what's happening. So because we have or, then we need to add them, which means it's going to be equal. This is A, right? And then plus B. Every time when you have or, that means you have to find probability of separate each one of them and then add them up. So let's see what we got here. We got 0708 0667. Let's see what is wrong here. I want to double check this one. What did we take? 100 and this one. Okay, we got this. And what is this 100? Okay, these two. Let's read the question again. A prime and B prime. Yeah. A prime is 100. Okay. We can do different way. A prime is 90 plus, let me do different way, equal A prime is gonna be 90 plus 10, right? It's A prime. And then we do plus, because it's or, we're gonna add it, right? So it doesn't matter, separate that or together. And then add B prime. B prime is 60. And then plus 10. Look what is interesting. That's why we got more. You see this 10 overlapping twice. See C3 twice, it came out twice. Let me move here and zoom it. I see. Do you see this? 10 is located, 10 is our C3. See, this is C and it's C3. And we used it twice, so it's a duplicate. Therefore, we need to take off one C3. You can't use the duplicate. So I'm going to do minus C3. Either take off C3 from here or do minus C3, this 10. Okay? All right. Closing parentheses. I didn't clean that C3. I just put minus C3, so make it crystal clear for you. So you cannot have duplicate. If it's duplicating, you have to take off one, right? And divide it by 240. Now we will get the proper answer. All right? .667. Okay, we got it. Moving to question number 15. Do we have 15? Yeah, 16 question. Okay, number 15. What do we have here? The following, for the following, state whether the event created are mutually exclusive and collectively exhaustive. Okay, what is mutually exclusive? Those are events, they cannot be exclusive, they cannot coexist at the same time. Let's say day and night, right? They can never coexist at the same time. What else? The dark and light at the same time, they cannot coexist. No, actually it wasn't perfect. In some cases, yeah, it can. If it's two pictures, you put one is light, one is dark, then coexist. What else cannot exist at the same time? Let's say age of person, 23 and 25 cannot be at the same time. You're either 23 or 25, correct? Okay. So those are mutually exclusive and collectively exhaustive. So a product was classified as defective or not defective. That's nonsense. We don't need that. It's additional. So the events are only mutually exclusive. That's not true. Doesn't have to be only mutually exclusive. They can be mutually not exclusive. The events are both mutually exclusive and collectively exhaustive. All right. The events are neither mutually exclusive nor exhaustive. No, it says whether the two events, this product was classified as defective or not defective. Now, in this case, either defective or not defective. So at the same time cannot be defective and not defective, right? So in this case, the events are both mutually exclusive. It cannot be at the same time defective or not and at the same time not defective. So therefore B is the answer. And the events are only collectively exhaustive. It's not going to work because we're going to have it mutually exclusive. We understand? Okay. So for the product which is defective or not defective, events are only mutually exclusive. They are not only mutually exclusive because they can be collectively exhaustive or not. And then second one, events are both mutually exclusive. Those are exclusive, mutually exclusive because it cannot be defective and not defective, right? And collectively exhaustive. And the C events are neither mutually exclusive. That's not true because they are exclusive mutually. And the events are only collectively. That's also not the case. It has to be mutually exclusive and collectively exhaustive. All right. How much we have? HR employee 128, right? So it's going to be equal total 128 divided by 401, right? Overall grand total. Okay. And we are getting 0.319. Okay, next question. What's the probability that randomly chosen employee is an HR employee? Here it is, HR employee. So total 128. Or, so first let's get HR employee, which is going to be equal. We already have here 01349, but let me put it there one more time. 128 total HR divided by 401. Okay, and then it says or, that means I have to put plus here, because when you have or, that means we are doing plus. Or, where is it? Here it is. Or indicated that absentee is an important metric to consider when evaluating effectiveness of employee engagement program. So shortly saying that indicated absentee, an important metric, and is non-HR employee. So here we have total HR 128 and absentees, total absentees 123. So it's going to be, no, hold on, let me do it over. So equal sign total HR divided by 401, and then plus we have, it says or absentees, yes, with absentees 123 over 401, and it says and absentees and non-HR absentees and is a non-HR, so it's gonna be plus and non-HR plus 73. Now, because in 123 that we punched, which is what? B12, I'm sorry, excuse me, B12. So it's including this 73 also, right? That's a non-HR and absentees. It's and non-HR. When it says and, we have to find intersection. Intersection of non-HR and absentee. So non-HR and absentee 73, because it's going to be duplicate, right? Because if I add 73, I need to subtract this 73. Over 401. Hold on. Let me do something for a minute. Let me see what it says. I'm going to do it over.